Hi guys, now that you have no trouble, hopefully, finding the number of protons, neutrons, and electrons in a particular atom, we're going to take that information and use it to build a model of the atom that we can put on paper as a drawing. We're going to use as our models Bohr systems. Bohr is somebody's last name, Niels Bohr, and Niels Bohr is a famous scientist we'll discuss later on in the class. Here's how you draw a Bohr model of an atom. You start with a circle of decent size in the middle, and that becomes your nucleus. The nucleus is just a fancy word that means the center of. So you often hear the word nucleus referring to a lot of different things, including a nucleus of a cell, but don't get confused because there's a lot of different meanings for the word nucleus, and they're not the same thing. Remember this, too. Cells are a lot bigger than atoms. You can fit billions of atoms in a single cell. So this nucleus contains two things, two types of particles, protons and neutrons. And what you're going to do after you draw your circle is write P equals and N equals, make them capital P and capital N. And then what you're going to do is you're going to go to your periodic table, and depending which atom you've been asked to draw, you're going to figure out how many protons and neutrons you have using the system I've already taught you. Then you have to fill in the electrons. Electrons are not in the nucleus. They are found outside the nucleus. And in real life, in an atom, all the parts of the atom are in constant motion. The electrons are moving near the speed of light. They're moving really, really quickly. So we would never be able to see exactly where they are, and their positions keep changing. And in real life, electrons don't follow neat paths like planets around the sun, but it's really complicated to draw them that way. So instead, what we do is we actually give electrons levels that they can go into based on how much energy they have. So you have three levels in this particular model. You've got the first level, which is right here. This is level 1. And these are referred to as energy levels. So that's energy we're talking about. Energy level 1, which is a low energy level. And then you have energy level 2, which is a higher energy level. And then energy level 3, and you can actually have more than 3 levels, but we don't work with atoms that are that big usually in this class. Sometimes, every once in a while, you have to draw a 4th level, but usually not. Now, the difference between these levels, again, is just how much energy the electron has. If you think about it, protons, whether you realize it or not, have a positive charge, and electrons have a negative charge. And this is what holds your atom together. They're attracted to each other. Your electrons, if they have more energy, can actually make their way further from the nucleus than they can if they have low energy. And that's kind of like almost a magnetic attraction, right? So the stronger or the more energy the electrons have, the more they can overcome that attraction that they have to the nucleus. And this should kind of almost remind you of the kinetic theory, right? As our particles speed up, they're able to move further apart. Same thing's going on here. As our electrons gain more energy, they're able to get further from the nucleus. Now, another thing that's interesting is that electrons are negatively charged, so they don't like to be near each other. They repel each other. And because of this, you can only fit so many electrons into each energy level before it becomes too crowded to stick another one in there. If it gets too crowded, it just kind of gets, the extra electron will get popped out like two magnets that repel each other because they're facing the same way. So each energy level can hold a certain number of electrons. The first energy level can hold a maximum of 2 electrons. The next energy level can hold a maximum of 8. And the next energy level can actually hold 18, but for purposes of drawing Bohr models, we pretend that it can hold only 8. So what we do is we just assume that the first energy level holds 2, all energy levels after that we're going to say hold 8. This is referred to as the octet rule, octet referring to the number 8. The octet rule says that for most energy levels in the atom, except for the first one, the number of electrons that you can have in that energy level or energy shell, they're sometimes called shells, is going to be 8. And not only that, but for reasons that we'll talk about later, atoms become more stable the more full their shells are. So if you have 8 electrons in your shell, on the outermost shell, we consider you to be a very stable atom. That's not the important part right now. Right now, the most important thing to realize is that when you're going to draw an atom, you're going to make a nucleus with the P and an N. You'll look up how many protons and neutrons you have. Then you're going to draw dashed line circles around your nucleus representing the energy levels that the atom has. And I'll show you how to look that up on your periodic table in a second, because you need to know how many energy levels you need. The next thing you're going to do is figure out where those electrons go. You're going to put them on those dashed lines, and I'll show you how to do this in a second. And you have to fill them in a very peculiar, special way. And don't worry about why right now. Just worry about learning the system. Okay, so I'm going to go ahead and draw a Bohr model for a sodium atom. And in order to do this, I have to find sodium on the periodic table, which I've already pulled up the part of the periodic table where sodium is. There he is. And let's go ahead and fill in the nucleus of our Bohr model together. So how many protons do you think sodium has? Hopefully you can see right away that he has 11 protons. How many neutrons does sodium have? Well, I need to round the 22 to a 23 and then subtract 11. And that gives me, let's see, 23 minus 11 is 12. 12 neutrons. Okay, next step. Because you really want them to kind of sit right on that line. And I want to put them right next to each other, not on top of each other. So those are 2 electrons, and that's all that fits in the first energy level. The next energy level can hold 8. And it's going to sound really silly, and you're going to wonder why, but don't worry about why. You have to put those 8 electrons into the next energy level using a special system. Here's the system. The first electron goes here, the second electron goes here, just like below. But then after that, you have to split them up before you double them up. So watch. Here's where the third one goes in the east. The fourth one goes in the south. Watch out, make sure you're in the second level still. The next one goes in the west. Now that's, so far we have 2 on top, 1 on the side, that's 3, 1 on the bottom, that's 4, 1 on the left, that's 5. I still have 3 to go. So the next one will go here in the east, here in the south, and here in the west. And again, I'm trying to hit the line, but I'm on an iPad, so it's not that easy. Okay, so now I've filled in 2 electrons in the inner shell, 8 in the outer shell. And remember, sodium has 11 protons, so he's going to have 11 electrons. So far, I have 10. The next electron gets to go up here. If sodium had more electrons, I would continue filling them in the same way I did in the previous shell, in the previous energy level. I would always do, except for the first energy level, you always go 1, 2 on the top, 3 to the right, the 4th one below, the 5th one to the left, and then you start doubling up. For sodium, it doesn't matter that much because you're going to fill in that second energy level. So really, you could have just put them in 2, 2, 2, 2, north, east, south, west. But this becomes a problem if you're doing an atom that you run out of electrons early before you fill the energy shell. So for example, if I wasn't doing sodium, if instead I wanted to do, say, sulfur, watch what I have to do. Okay, so I've brought up sulfur. Here's sulfur. And so I can use this information to fill in my protons and neutrons. So how many protons does sulfur have? Sulfur has 16 protons. That's his atomic number right here. He has a rounded mass of 32. 32 minus 16 is 16. And now I need to put in my electrons. So following the rule that I've taught you, how many electrons total does sulfur have, first of all? Well, he's going to have 16 total, right? But how many can go in the first energy shell? Just 2. 1, oops, got to change to a black color, otherwise you won't be able to see that, right? There's 1. Hello. Sorry, guys. Technical difficulties. There's 1. There you go. And the other one also goes right next door. So far so good, right? Now I have to keep going. The next energy shell can hold 8. And that's 1, 2, 3, 4, 5, 6, 7, 8. And you can laugh if you want to. Oops, kind of got carried away there. Almost had 3 electrons over there on the left. Okay, so now That fills in, right? So now I have a total of 12. 2 in the first shell, 8 in the next shell. Sorry, that's 10. Can't add. Now I need 6 more in my next shell. Here's where it's going to matter how you put them in, because watch what happens. Following the rules, I do 1, 2, 3, 4, 5, 6. If I do it that way, you'll notice I get one electron that's by itself here and another one that's by itself here. If I didn't put them in following the spread them out around the edges rule, then what would happen is I would get this. I'll do it in red, what would happen if I didn't follow that rule. I would do this in red. 1, 2, 3, 4, 5, 6, which would leave an empty space over here, which would be no good. That will mess you up later when we start learning about how atoms bond. So therefore, you gotta follow this system. The system is easy to learn once you give up on trying to understand why. I will teach you why later once you're really good at just doing it. But for right now, don't try and understand why. It'll just mess you up. Trust me, I've been doing this a long time. The system is very easy to understand. You do 1, 2 together, and then, if there are more, you spread them out. The third one, the fourth one, the fifth one, then the sixth one, then the 7th one, then the 8th one, like that. So it's just a question of always spreading your electrons out when you're in the east, south, and west positions before you double them up. Okay, so now what you're going to need to do is spend some time practicing in class, and when you get really good at this, we'll be able to move on to the next step, which is learning how to make an even simpler model of the atom that'll be useful to us when we do bonding. Bonding is the story of why some atoms react with others while other ones don't react at all, and this will teach you the secrets of how things chemically react and why things chemically react, and that'll be a lot of fun. I'll see you guys in class.